Hello everyone, this is the video lecture for Precalculus 3.4. So, if you've seen now, we went through 2.7 and 2.8, now we're in 3.4. It's kind of just a mixed bag of review sections is what it really is. So, we're going to be talking about zeros here today. Zeros. So let's talk about zeros. In fact, let me just give you a real quick brief overview of this. Zeros are whenever a graph crosses or touches the x-axis. So all those are zeros. You can touch, you can cross, whatever you got to do. That is a zero. The very first thing that they're going to talk about here is 34008. They're wanting for s of x equal to 6x to the fourth minus x squared plus 6x plus 12. They only want the possible rational zeros. Maybe you've seen that before. I often do the acronym PRZ in my classes. Let me give you the formula of this thing just to remind you. This is factors of the constant term divided by factors of the leading coefficient. That's good enough. What are they talking about? They're saying the factors of the 12 go in the top. 1, 2, plus and minus for all these. 3, plus or minus 4, plus or minus 6, plus or minus 12. It's all on the top. Factors of the leading coefficients, this guy, they go in the bottom. There we go. 1, 2, 3, and 6. Okay. Back in the day, there was this thing called paper tests. I know, it's so strange. Who would ever thinking? And on paper tests, when I graded it, I said, hey, put the possible rational zeros. People would put that, and I would say, great job, you're done. They don't want that in WebAssign. They want you to write it out. Yep. They want you to type out every possibility. So that means everything's going to be divided by the 1. Everything's going to be divided by the 2. Everything's divided by 3. Everything's divided by the 6. Here we go. 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, 6, negative 6, 12, negative 12, comma. We're going to keep going. I don't have enough room. Here, there you go. Everything divided by the 2. 1 half, negative 1 half. 2 over 2 is a 1. We already got that, so that's good. 3 halves, negative 3 halves. 4 over 2 is 2. We already got it. 6 over 2 is a 3. 12 over 2 is 6. We already got it. Okay, everything divided by 3. 1/3, negative 1/3. 2/3, negative 2/3. 3 over 3 is a 1. We already got it. 4 over 3 we don't have. 6 over 3 is a 2. 12 over 3 is this. Okay, 1/6. Here, this is all in the big box here, by the way. If you run out of room, well, it's kind of unforgiving. It's everything divided by 6, 1/6. 2/6 is actually 1/3. We already got it. 3/6 is 1 half. We already got it. 4/6 is 2/3. We already got it. 1 and 2. We already got it. Okay. So this is your answer that you type into WebAssign. Again, it's all one huge line, just one big one line. I just can't show that here on the screen. Good luck typing all that. Sorry about that problem. But at least we don't have to do anything else with it. So what are the possible rational zeros anyways? These are the possible answers for this polynomial. So if I were to start guessing, I better start guessing from this. I'm not going to guess 5, because 5 is not one of my answers here. I got 4 and 6, but not 5. I would guess, I would not guess a 7, because 7 is not part of my list. I would not guess a 9, but I would guess 6 maybe, or a 3, or 1/2. Those are all possibilities. So they're a list of good guesses. Okay, next question. That's a 4, by the way. We're in 3.4. So it says find all the zeros and then write in a factored form. That's at the end. So we got p of x is equal to x cubed plus 6x squared minus 32. And they say, go, figure out, solve for x. I am going to cheat right here in front of you right now. I'm not going to actually show it, though. I'm sorry. But you can just go to Desmos, desmos.com, graph, type this in. What does it look like? Looks something kind of like this here. I'm going to try to do my best here, okay? That's not too bad. This guy here is at -4. This guy here is at +2. And it's kind of interesting because you have a touch point here. And if you kind of remember, touch points have a multiplicity of 2. So you actually have -4 multiplicity of 2. It's not just 2. They could have, it's an even multiplicity. I'm just guessing 2 because there's a total of 3 answers here. And then we got this 2, just multiplicity 1, I guess you can say. So how would I put that in my answer here? Well, this is what I typed. Apparently this was okay for you to type it like that. I don't really know if they want you to type just this. Like, would that work? I don't know. This worked. That's what I have on my paper. I'm going to leave it like that, okay? So I'm repeating that -4 because it's a touch point rather than at 2 you simply just cross, which often just means multiplicity 1. It's an odd multiplicity. But if you want to go on to multiplicity, that's a whole other thing. Really here, you graph it on Desmos, you got your 2 answers, you put them in, you're done. Factor form comes from this, and so really we got x plus 4, again squared, that's your multiplicity, and then x minus the 2. So that's your final answer that they want at the end, the factored form stuff. All right, I cheated. And how would I then not cheat? So here's the thing, pre-cal class. Listen here, I'm saying that you can use graphing calculators, you can use Desmos for your homework. I mean, of course, why not? And I would say the only reason why not to is it would be developing too much of a reliance on that skill, too much reliance on the calculator. Because you're expected to have only a scientific calculator on the exams. So this sounds a little counterproductive, well, I'm learning all about the calculator and you take it away from me. I don't make the decisions. But I do think it is a good idea to do this this procedure by hand. Not only because, yeah, we're going to maybe try to train ourselves and all that stuff, but there's other problems coming up here in just a minute where you have to do it by hand, and Desmos and all your other calculators ain't going to help you. I can nearly guarantee that. So what I'm trying to say is that don't rely on these outside things. Use a calculator to verify, double check, and all that stuff. So can you do it on the calculator? Yes. Should you do it on the calculator? Maybe. I'm not saying no, just maybe. What if you need to get your homework done? It's like, last minute, only got an hour left until the due date. Just use your calculator, get it over with. You know what I mean? It I would hope you don't wait till that time, that last minute. But I mean, I'd rather you get a good grade up front, and then you can go back and learn how to do it. You know what I mean? So that's just my opinion. Don't quote me on that. So let's go back, and we're going to do this without a calculator, okay? Without a calculator, how do I get those answers? Well, first off, that was the reason why we were doing the possible rational zeros on the very first problem. Now, they're a whole different list here. But I'm saying the reasoning behind it is to find good guesses. So 1 is we're looking at this guy right now. 1, 2, let me start listening up some more. 4, 8, 16, 32. Okay. And factors of the 1, you see the 1 is in the front, right? There's just 1. Thankfully, there's not a lot of fractions here. But, notice, these are my possible answers. Am I going to try any numbers that are 5 or 3 or 7? No. I'm going to try 1, 2, 4, 8. So what I'm going to do is going to try, test, guess each one of these one by one going down the list. Now, you don't have to write this out like you did on the other one. That would just take too long. You don't need that. You could see simply 1s, 2s, 4s, and 8s. So I'm going to try with a positive 1, starting with these numbers right here. Okay, the coefficients, this is synthetic division. It's been a while if you've maybe not done it for a while. That's an x cubed. Notice 6x squared. 0x. How many x's you got up here? Regular x's. 0. That placeholder is very important. Okay, don't miss that. 1 times 1 is 1, plus the 6 is 7. 1 times 7 is 7. 0 plus 7 is 7. 1 times 7 is 7. And then we don't get 0. I don't care what we don't get 0. I know I'm going kind of fast on synthetic, but I'm assuming that you've seen it again in college algebra. If you haven't, well, it's very simple. All I'm doing is multiplying, and then I'm adding, and I put it up a row, and then I add. So multiply, 1 times 1 is 1, and then I add 1 plus 6 plus 1 is 7. And then 1 times the 7 is 7, 0 plus 7 is 7, 1 times the 7, oops, overshot it, 1 times the 7 is 7, and then I don't care what this is, again, we're looking for 0 here. I'll show you why I'm using synthetic here in just a few minutes. Well, also because it's super fast. You could use long division, I guess, if you want to. Negative 1 times 1 is negative 1, plus the 6 is going to be a 5. Negative 5 plus 0 is a negative 5. 2 negatives make a positive 5, and not 0 yet. Again, so I tried both of these. They didn't work. Let's try 2. Now, we already know the answers, but I'm trying to show you what I would do if I didn't have a calculator, if I had only a scientific, you know. 2 times 8 is 16. 2 times 16 is 32. And magically, we got a 0. So I know that x equals 2 works. That's one of my answers. Like if they say x equals what? Put a 2 in there. Okay? Now we got to keep going. This is what's left over. Again, this was x cubed. Now this is an x squared. You reduce its degree by 1. So we get now a 1x squared plus 8x plus 16 is equal to 0. You don't need that 1, obviously. So I want to factor this thing. And it's factorable at this point, at least. I think a plus 4, right? And of course, now you can see x equals negative 4. X equals negative 4. There's your multiplicity 2, because there's 2 of them there, right? And again, I'm pretty sure WebAssign takes it like that. They might take it, you know, just a 1, and they're still okay. I don't know. But definitely that's what I have on my paper, and so there you go. And then you work backwards to find the factored form. There you go. That was it. Whew, that was a big problem. Mainly because I wanted to show you 2 different styles of doing it. It's actually not that big of a problem. This one here is a bigger problem. P of x. P stands for polynomial, by the way. 3x cubed plus 5x squared minus 7x minus 9. Again, same thing. Find the zeros. Go from there. Well, my possible rational zeros here, I'm not going to graph it this time, are 9s and 3s. So 1, 3, 9. And then on the bottom, we got a 1 and a 3. So like 1/3 is a possibility. But besides that, I think it's just the numbers at the very top. So I'm going to just start trying numbers. Let's try 1. It's always a great number to start with. 1 times 3 is 3, plus the 5 is 8. 1 times 8 is 8, plus the negative 7 is a positive 1. And 1 times 1 is this, and we don't get a 0. Again, I don't care what we get. We're not getting a 0. It doesn't matter to me. If we get a 0, I'm happy, and we do stuff differently. So negative 3, 2, negative 2, negative 9. 2 negatives make a positive 9. Aha! So x equals negative 1 for sure. That's one of my answers. What are we left with? Well, I got 3x squared plus the 2x minus 9 equals 0. I'm wondering, well, now what do I do now? You guessed it. Quadratic formula. You got it. So I'm really hoping you definitely remember this stuff. But that's, I'm going to use capitals if you don't mind, because my lower cases are weird. So negative b plus or minus square root of b squared minus 4ac, all divided by 2a. Again, this is my a, my b, and my c. All right, here we go. Negative 2 plus or minus the square root of 2 squared minus 4 times 3 times the negative 9, all divided by 2 times the 3. So I'm going to simplify a tiny bit. We got 4. 2 negatives make a positive. 12 times 9 is 108, it seems. That's what it says on my paper here. That's nice of me. And so that's 112 and divided by 6. Now, back in my math lab days, remember that we had to take this and do its prime factors and blah, 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 blah. No, 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 no. We're in WebAssign. No simplifying. Required, at least. So, like, what's my final answer here? Well, we definitely had the negative 1. And then I had this guy. So I had a negative 2 plus the square root. And then I had a negative 2 minus the square root. That's what it looks like. I think that there might be a plus and minus button somewhere in that that list on the side whenever you're answering one of these things. And if you click it and it works, cool. If it doesn't, I don't know. So I just write it out manually myself personally. So there's the answers. Next question. We're just going to repeat this process like 100 times. Okay, maybe not 100, but a lot. 2x cubed minus 11x squared plus the 12x plus the 9. I mean, what we're getting here is a lot of good practice. So factors of the 9 in the top, factors of 2 on the bottom. So we can have all kind of fractions, 9 halves, 3 halves, 1 half, all kind of stuff. But I don't want to try with fractions at first. Who wants to start with fractions, right? So let's try some whole numbers. Just basically the top numbers are a good safe bet to start with. So we got a 2, negative 9, negative 9. We got a 3, and that is not 0. You would think eventually I would give up on that positive 1. It just doesn't happen. Negative 2, negative 13. 2 negatives make a positive 13. Oh my, this is way not going to work. Okay. The next whole number is a 3. Again, I'm just trying stuff out. 6, negative 5, negative 15, negative 3, negative 9, right? 3 times 3 is 9. Aha! We got it. So what do we have left then is the 2x squared minus the 5x minus the 3 is equal to 0. Well, now what? You can factor this. I'm looking at my answers. You can factor this if you're good at factoring. Or you could do quadratic formula. Or you could just keep on trying numbers, like with synthetic division. Now, we know that negative 1 and 1 don't work. 3 worked. What if we had 3 again? Again, see how I'm using the new numbers? I don't know if you've done it with only 3 that much, but I'm trying the same number with new numbers here, with my answers, I guess you can say, and we're going to just see what happens. And look, it worked again. That doesn't mean like, oh, every number works twice or 3 times. No, 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 no. I'm saying that we have a multiplicity of 2 now. Like, it happened once, it happened again, so we got a multiplicity of 2. That's going to be a touch point on the graph. Okay? We don't have to graph it, I'm just saying. Actually, I don't know. Maybe you do have to graph it. I have a graph at the bottom. But regardless, I'm not thinking of the graph right now. I'm just saying it happened again. And then my answer here now, this was x squared. Now it's just a plain old x. 2x plus 1 equals 0. Move the 1 over. Divide by the 2. Negative 1/2. So that's my other answer. So let me list out my answers here, if that's okay. I got a 3, I got another 3, and then I got a negative 1/2. Okay? Again, did they want you to type it like that? Do they just want this guy? I don't know, but that looks pretty good. I didn't actually put mine all in one box on my paper. So I'm sure that it's pretty understandable once you start doing it. On my paper, I have that I was graphing it. And I think that's a good strategy regardless. I want to see, can I graph this from the information that I've been given? Well, notice if you go way, way back here, at the very beginning, we got this guy. In algebra class and whatnot, I like to call it the boss. He's the boss. He's the biggest power. The boss always has the biggest power, the most power. Okay, whatever. Anyways, and he's got a degree of 3. And so what that looks like is it's going to be like this. Notice that it's positive in the front, degree of 3. It's a cubic. That's basically my graph right there. Boom, we're done. Well, let's put that together with this guy. So my basic graph looks something kind of like a cubic, but with these guys, remember that this is now a touch point, and this is going to be just a cross through. So getting it all number linedy. This guy is my negative half, 1, 2, and 3. So I'm going to cross through this guy, and then when I'm coming this guy, I'm going to just touch him, bloop, and then go on off. There you go. There's my graph. See how you can utilize some of this stuff here. Now, if you're thinking, hey, I don't remember this whole boss thing, like what the heck are you talking about here? Leading coefficient test, or another thing that I often do is end behavior. Again, this is just review from algebra, and I'm not going to focus on that because the section doesn't focus on that. But end behavior, leading coefficient test, if you want to go look it up again. All I'm saying is I want a rough graph of what it looks like. What is the rough graph that the boss would give me? Get rid of that stuff. Well, this is my rough graph that the boss would give me. And then I basically fill in the pieces to make it look better. Okay? That's kind of the basics. Could you use Desmos to graph it? Yes, you could. I'm just showing you another strategy, another style, so that you're ready for times when you're not having that calculator available. Okay? 34086. Now, this one I actually did not do at all. I'm just going to give you what I said here. It says, watch out. I wrote that on my paper here. It has rational and irrational zeros. And by irrational, it's actually an interesting thing. I don't know if I was really meaning this stuff or not. Was I also meaning like imaginary? I don't know. They're not the same. That irrational square rooty stuff. Rational like fractions and stuff like that. So I can't remember exactly what it means. Maybe I also meant like imaginary. I don't know. I might have mixed up my words. But regardless, what you're supposed to do on this problem, whenever you get it, is quadratic formula. And that'll tell you everything that you ever needed to know. So quadratic formula, and of course possible rational zeros, and then this, and then you get your answer. And we've already done it a lot of times. Apparently this was an important question on your homework. Just watch out for it. You can have both of these together. I don't really know if I meant this thing or not. Moving on. Just quadratic formula will tell you everything you need. 34095. This function's very small. X to the fourth minus x minus 6. And it says use a graphing calculator. Now, hold on. How can you tell me to use a graphing calculator if you're going to take it away from me on the exam? Yeah, that's a great question. I am supposing, and I've taught this class a couple times now, I'm supposing that the exams will not include this. So I'm going to say right now, this is not on an exam. When they're doing this stuff, they're trying to make you learn all the tools. You see, graphing calculators are not bad. Desmos is not bad. TI-83, not bad. Casio, not bad. But we're also not one to rely on it. So we're just saying, hey, there's a couple questions here. Just saying, hey, go ahead and graph it, see what you do. And it's a good strategy. But ultimately, should not be on an exam. Okay? And if you find something on your exam that says use a graphing calculator and you're not allowed to or something, just tell me. you know, we'll figure it out. I'll send it up to the boss. Um, so I just went to the graphing calculator and did it. I don't even know what the graph is. I got this from Desmos, I'm sure. 59723, and they were decimals, and apparently that was okay for WebAssign. They were okay with decimals. So there you go. The end. Move on. 3, 4, 100. Okay, let's talk about this. This says use graphing calculator. It says that. Okay, but I'm going to tell you, you do not need to use it, nor do I recommend you using it. I don't even know how you'd use it, honestly. It makes no sense to me. I'm going to do it for you. I'm going to do this problem with you, but if this shows up on an exam and it says this, you're going to have to ignore it. Now, see, this is the thing. I've been through this class a couple times, right? I've seen these problems a couple times, right? So when I set up here, use a graphing calculator is not on an exam, but now I'm saying, hey, use a graphing calculator. It might be on an exam. Okay? Well, now, that sounds contradictory, right? I'm just saying, this particular problem here, you don't need to really use a graphing calculator. So just ignore that, okay? And if you ignore that, then it might be on an exam, right? That's just the thought. I don't make the exams. I'm just saying, I just go through with the class. I don't actually make any of this stuff up myself. But that's okay. I'm just telling you as it is, so that we're all understanding what's going on. Okay, so this is an important question. We definitely got to talk about it, and you're not going to use a graphing calculator. There you go. Okay, so they got this box. I didn't draw it perfectly. That's a diagonal right there. It says the area of this whole rectangle is 6,000. And then they have an X. It's a rectangle. The Y. And then they say this is X plus 10. That distance, the diagonal distance, is X plus 10. What they're wanting to know is what is X and what is Y. That's the entire problem. There you go. And somehow I'm supposed to use a graphing calculator about this? No. Don't even, just ignore it, okay? So we're going to move on. Well, first off, I'm going to use this area. An area is going to be length times width, or whatever you want to call it. So X times Y is 6,000. Okay, so that's my area formula. The other thing that I can do, actually, from all this is the Pythagorean theorem. Pythagorean? I think I spelled it right. There you go. Basically, it's going to be this x squared plus the y squared is equal to r squared, or hypotenuse squared, or whatever you call it. Well, that's, in this case, x plus 10 squared. Okay? So we have, right now, looking right here, I'm going to use a different color, we have two formulas and two unknowns. We have two equations and two unknowns. Again, that's the x and y. Meaning we can do this. We can solve for x and y given what we have in front of us. Again, I'm going to ask you right now, how would you use a graphing calculator at this moment? Maybe, I don't know. There's got to be a way. But I'm not going to go through that because, again, ignore that. Let's keep going, okay? We definitely can do this without a calculator. So what I first tried, I'm just going to tell you what not to do. What I first tried is I said, oh, you know what? I'm going to take this guy here, and I'm going to say y is equal to 6,000 over x, and then I'm going to plug that guy in right there, and disaster. No, I'm telling you straight up, I got to a certain point, and I said, no. I said, no, this is not going to happen. So don't. That's what not to do. So what should you do? What would be that first good step? Well, I'm going to FOIL this guy out. And so that's x squared plus 20x plus 100. Now, I did that really quick. Basically, 10 times 2 is 20. 10 times 10 is that. Again, 10 squared. 10 squared is this. 10 times 2 is that guy. Okay. Well, notice that my x squares cancel. That's really helpful. Actually, I think I will plug that thing in here in a second. Let's see. Yeah, I like what I got here. So let me rewrite. I got y squared is equal to 20x plus 100. And I also have this xy. Let me write it a little bit better. Xy is equal to 6,000. And there's a couple ways we can go about doing this. I think if I solve for x, it might be a little bit... solve for y. I might be a little better. So I'm going to say x equals 6,000 over y. Again, you could do either way. And what I'm going to do is take this and plug it in right there. So that I have now this guy here. Plus the 100. Okay, again, there's lots of different ways to do this problem. This is just the way I apparently chose, and it works. Okay, cool. I am now going to... It says... That's funny how I did that. I said on my paper here, said, now use a graphing calculator. No. Let's not. I already went through all the process of saying no. And I'm for reals, though. Give me 1 second here. So I've got y squared. I'm going to multiply these two at the top. 1, 2, 0, 0, 0, 0. Yep. Divided by y plus 100. In order to get this y out of here, what I'm going to do is actually multiply both sides by y. And you get y cubed. This y goes away entirely. And we got a 100y right there. Move this guy over. Y cubed minus 100y. Let's move this guy over as well. Minus 1, 2, 0, 0, 0, 0 equals 0. Okay, now, pause for a minute. What do I do now? How do I start solving for this thing? Well, possible rational zeros. That would take forever. Maybe I'm going to go back on my word about the graphing calculator. It did say that at the very beginning. And so perhaps it's not on an exam. All I'm going to do is follow instructions. Okay, well, now you can see the lecture experience here. I did, of course, prepare, and I knew all this stuff. I guess I skipped this detail when I was looking through it all. Regardless, let's just say I use a calculator right now, finally, and I'm going to solve for y and all that stuff like that. Well, I get 50, straight up. And if you plug that into the x equals 6,000 over the y, 6,000 over the 50, you get 120. And so then, very simply, we have our y is this, our x is that. But now, WebAssign asks it as smaller and larger. And so you would say the 50 and the 120 there. Okay. So, I know I talked a lot about the calculator. No, we're not going to use a calculator. And then all of a sudden at the very end I did. Could I actually not use a calculator and still get to this? The answer is yes. I would do the possible rational zeros. It would take me a while, if you noticed. But eventually, there is a possibility of very much of getting there. I'm not going to go there right here. I'm not going to even recommend you doing that. I'm just saying that I can't exclude this from an exam, okay? I just know that this is an important question, and I know that there's limitations. So I'm just going to be as straight and honest with you as much as possible. This is an important question. Learn this question. Learn this question as much as you can without a calculator, and if you have to, here at the very end, you're just following directions, aren't you? Next question. So 34105. So I have a box, and I have B. They use lowercase b, so I'm going to try my hardest there. B and L. So it's like a box that you ship, like a cardboard box you get in the mail. What they're saying, their formulas are very strange here. They're going to say girth plus length is equal to 108. And I'm like, awesome, bro. I know exactly what you mean by girth. What their real formula is 4B plus L is equal to 108. The girth is 1, 2, 3, 4. And of course, You know that UPS and FedEx use girth as part of their formula of calculating. No, they don't. Okay. Anyways, they also say that the volume is equal to 2200. Okay. Well, this one's a little bit easier. B times L. So B squared times L is 2200. Now notice we have this one and this one. Two unknowns, two equations. We should be able to solve this without a calculator. No, I'm serious. Okay? These are very important questions that I'm going over right now. So don't take it lightly. Don't say, oh man, he just used a calculator. I'm serious. This is important. I wouldn't be saying it if I didn't think it was. How am I going to solve this thing? Honestly, I feel like if I solve for L and plug it in, I think I'll be able to get an easy answer there. So I'm going to move this guy over. L is equal to 108 minus the 4b. And then I'm going to plug that in right there, basically. So then I got b squared times the 108 minus 4b is equal to 2200. Distribute your b squared. 108b squared minus 4b cubed is equal to 2200. Okay. Now what? To be fair, I'm actually going to move these over so that I get a positive 4b cubed minus the 108b squared plus the 2200 is equal to 0. This is what we now need to solve. Now, I think that we can actually factor out a 4 from all of these. Let me just real quick. 108 divided by 4, does it work? Yep. And 2200 divided by 4 definitely should work. So we got b cubed. Here, let me write it more clearly. Factor a 4 out. B cubed minus 27b and then plus the 550 equals 0. Now, possible rational zeros, all that kind of stuff. Factor it if you can. Well, not very friendly. It's not very friendly. And so this one does not have in the directions to use a calculator. It doesn't say that. They're going straight up with don't use a calculator. Well, I'm going to use a calculator at this point. And so I got b is equal to 5. You can go back and plug this into the L equals 108 minus 4 times the 5. And you're going to get 88. And so I don't know if they're just wanting the L or the B and the L, and you have to put them both in. I don't know, but there you go. That is all. And that's the last question I have. Now, I just, again, want to say, I know it sounds kind of confusing to, don't use a calculator, and then all of a sudden you use a calculator. But I can't use a calculator on an exam, and, blah, blah, blah. This might be an exam. Everything's going to work itself out. Don't worry, okay? I'm just saying, I seem vague, but the class is designed for you to be able to do these problems properly. That means it's on the homework. Use a calculator. If it says use a calculator, use a calculator. If it's something hard like this, use a calculator. It's just not the homework. On a quiz, those quizzes, do whatever you want. So yeah, pull out a calculator. On an exam, if it says there's not a calculator available on an exam, well, you should expect those questions to be done without a calculator. That doesn't necessarily mean those are going to be on there. But the final exam, as I'm told, is that they will let you have a graphing calculator on the final exam. Huh. Then I should probably start using my calculator. Okay, that's the end of my lecture. Thank you very much. Have a great day.